Okay, so in this video, we're going to go ahead and take a look at a way that we can just have to memorize a certain amount of information from this very exhaustive trigonometric chart that we made here, and use reference angles and all of the quadrants' positive values that we learned in the previous video to go ahead and evaluate trigonometric ratios. Okay, so let's go ahead and take a look at the part that we are going to grab from the exhaustive list of functions on the side here. Okay, so using this method, we can go ahead and just basically memorize this part that's in that yellow rectangle there, and put it over here. So, and use small sketches of the unit circle to go ahead and start to put these pieces together. So let me go ahead and fill in the rectangle to the left here. Okay, so here is this chart here, and what we're going to do is that we're going to do the first example, and I'm going to fill them in as we go, and I'm going to do as many examples, let's do 8 of them so we can see how this works. All right, so here we go. And notice that I have removed the chart because we don't want to lean on that thing the entire time that we're doing these. We want to use this method because, again, this method is going to help us streamline what we've learned, okay? So if I look at the sine of 120 degrees, we know that our reference angle is going to go ahead and, our angle is going to look like this. So here's our 120 degrees. Now, if that's 120, we know that our reference angle is going to be what's left over to make 180, so this is going to be 60 degrees. So we're going to have a 60 degree reference angle. So we rewrite this as the sine of 60 degrees. Now, to do the last part, okay, is that we're going to take a look at where the terminal side has, and that's this guy right here, has landed. Notice that it's landed in sine's quadrant. So that means is that the result is going to be positive. Then I just need to look up top and find the sine of 60 degrees, which is going to go ahead and be root 3 over 2. So I know that that is going to be the square root of 3 over 2. Okay, let's take a look at another one. Okay, in this one we have the cosine of 135 degrees. So that means is that it is going to go ahead and be right here, and that guy is going to be the 135 degrees, and the reference angle that is going to complete the 180 is going to be 45. Okay, so we rewrite this as the cosine of 45 degrees, and we notice that the reference angle, or I should say the terminal side right here, has stopped in Sineville. Now, that basically means is that cosine is going to be negative there because only sine and its reciprocal are going to be positive. So therefore, that's going to give us a negative square root of 2 over 2 because the cosine in the reference angle is going to be the 45 degrees right here. So you can see that a reference angle is handy because it's always going to go ahead and put things back into this chart here, and we don't have to memorize that entire giant chart that was off to the side over here. Okay, let's do... Okay, in this example, we're going to take a look at tangent, and we also introduce some radians here. With radians, I just want to go ahead and make sure that we need to go ahead and find where the angle is going to, the terminal angle is going to land. And so I want to make sure that we, again, go back to the way that we found the radians before, going, all right, well, if this is going to be a 4 right here in the denominator, we know that we want to count around the circle, go in 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And so we know that it's going to land right here, okay? So we don't want to lose track of how we got those to begin with. So if I were to look at each one of these increments are going to be pi over 4s, right? And I found out that this angle is all the way over here. So it looks like that one chunk is going to be the reference angle right here of pi over 4, okay? And so therefore, looking at the bottom part here, we got the reference angle right here of pi over 4. So, and let me draw the original in here. Okay. And so what we want to do then is that we have then, we're rewriting it as the tangent of pi over 4. Okay. And the tangent of pi over 4, we know from the chart right here, the tangent, same thing as 45 degrees, is going to give us 1. But we know it's going to be negative because it landed in the cosine part. So when it does that, we know that we have to put a negative here because it is not, tangent is not cosine or the reciprocal of it. It's tangent. Okay, so it's going to be negative. So that's how you'll do those guys. And I want to take a look at a negative angle as well in this next example. Okay, so it looks like we're going to tackle the tangent of a negative 120 degrees. So if we're going negative, remember is that we have to go in this direction here. And remember that that little guy right there, that's 90 degrees right here. So 30 degrees past that is going to give us that 120 degrees, where the reference angle is going to be 60 degrees right here. So the reference angle is going to be 60, and we want to rewrite that as the tangent of 60 degrees. So that said is that we look, and we know it's going to be positive because it's in the right quadrant. That's good. And we know that the tangent of 60 degrees is going over here to the table, and the square root of 3. And so therefore, the tangent of a negative 120 degrees is the square root of 3.